Hello, my dear students. Welcome to KUTV Elimu Live. My name is teacher Kelvin Fudi Wanyabura from Lakewood Senior Girls. We are going to learn mathematics, a very interesting topic, the topic indices. The topic indices. So that is the topic that we are going to handle, the topic indices. And in the topic indices, for us to be in a position to answer questions on indices, we must know the laws of indices. We must get to understand the laws of indices. And then after understanding the laws of indices, we must understand how to apply these laws of indices. So at the beginning, we are going to have the laws of indices. Then after the laws of indices, we are going to have several examples on the topic indices. So you write laws of indices. Laws of indices. The first law of indices, is a to power x times a to power y is equal to a to power x plus y. A to power x times a to power y is equals to a to power x plus y. What do we mean by this law of indices? What we mean is that if the bases are the same, we call these bases. Just a review. Indices is the plural of index, and an index is a power. Indices is the plural of an index, and an index is a power. So whatever we are calling indices in this case is the power. So in the topic of indices, we'll be having the base and the power. We'll be having the base and the power. So the first law of indices that we have stated here is if the bases are the same, both of them are base A, we have a multiplication sign separating the two similar bases. We can write that base as just one value and then add the powers. We normally say that in indices, if the bases are the same and we have a multiplication sign, we normally add the powers. For instance, if given, for example, if given a question like this, 2 to power 3x plus 5. 2 to power 3x plus 5. 2 to power 3x plus 5 is in this form. Is in the form a to power x plus y. So how can we separate? How can we separate the 3x and 5? By introducing a multiplication sign and rewrite it as 2 to power 3x times 2 to power 5. So this was one base, 2 to power 3x plus 5. Since the powers are addition, we can rewrite it as 2 to power 3x multiplied by 2 to power 5. That is the first law of indices. Law number 2. If the bases are the same and we have a division sign, we subtract the powers. If the bases are the same, and we have a division sign, then we are going to subtract the powers. That is law number 2 of indices. We are going to subtract the powers. For example, 3 to power 2x, 3 to power 2x divided by 3 to power y, it is the same as 3 to power 2x minus y. Because the bases are the same, and we have a division sign, we are going to subtract the powers and it will be 2x minus y. Law number 3 of indices. Law number 3 of indices, we are going to have 1 over a to power m. 1 over a to power m is equal to a to power negative m. What do we mean by this law? If it was 1 over a certain number to power another number, then if we want to bring a to the numerator, if we want to take this denominator, it's 1 over a, and you want to work out with it as a, not 1 over a. You want to work out with it as a for simpler working out. You must change the power sign, or the sign of the power. So 1 over a to power m will be the same as a to power negative m. You change the sign of the power if you reciprocate. Law number 4, we have x over y to power m is the same as y over x to power negative m. We have reciprocated x over y to power m. So if we get the reciprocal or reciprocate x and y, we'll have y over x to power negative m. Law number 5 of indices is a to power x into bracket to power y. It is the same as a to power xy. You multiply the powers. This bracket means multiply the powers. So a to power, we can have an example to understand that law better. A to power 2 into bracket to power 3. This will be the same as a to power 2 times 3, which will give us a to power 6. That is law number 5 of indices. Law number 6 of indices. We'll have this law where you are given a to power m over n. A to power m over n. A to power m over n will be the nth root. The denominator's root. The denominator's root. That is nth root to power the numerator m. The nth root, denominator's root to power numerator. For example, if you have 5 to power 3 over 4, 5 to power 3 over 4, it is the same as the denominator's root, that is the fourth root of 5 to power numerator to power 3. Those are some of the important laws of indices that we need to apply in the questions of indices for us to understand it better. So, having understood those laws of indices, then we are going to have several examples on indices. Several examples on indices. So examples of indices. So it's mathematics. The topic is indices. Example number 1. Solve for x in solve for x. Example number 1. Solve for x in 4 to power x plus 1 to power x plus 1 is equal to 32. 4 to power x plus 1 is equal to 32. So the first thing when solving questions on indices is to look at the bases. I said there is the bases and there is the powers. We have a base 4 here and we have power x plus 1. Look at these two bases. Ask yourself, is there a possible way of making the bases to be the same? If the bases are even, you start by raising to base 2. We ask ourselves, can we raise 4 to base 2 and also raise 32 to base 2? 4 to base 2 is the same as 2 to power 2. Yes, the answer is yes. We can raise 4 in base 2. Where we'll say 4 is the same as 2 to power 2. Remember, we had x plus 1 at the index is equal to 32. 32 is the same as 2 to power what? 32 is the same as 2 to power what? 32 is the same as 2 to power 5. Is the same as 2 to power 5. Now, my dear students, the bases are the same. The bases are the same. If the bases are the same, we equate the powers. We equate the powers. Since do not equate the powers if the bases are not the same. If the bases are the same, we equate the powers. So we'll have 2 into bracket x plus 1 is equal to 5. Open the bracket. 2x plus 2 is equal to 5. Take 2 to the other side. 2x is equal to 5 minus 2. 2x is equal to 3. Divide both sides by 2 and your x, sorry, not your x, the value of x is equal to 3 over 2 or 1.5 or 1.5. My dear students, just a recap. Make the bases to be the same if it's possible. There are cases that is not possible, and I'll show you how to deal with such questions. If it's possible, make the bases to be the same. After the bases are the same and we have an equal sign, just drop the bases and equate the powers, then solve for the value of x. That was example number 1. Example number 2. Example number 2. Solve for x in solve for x in 9 to power x plus 3 to power 2x minus 1 is equal to 53. Solve for x in this particular equation. Now, when you look at this equation, we have 9 to power x. 9 is the base, x is the power. 3 to power 2x. 3 is the base, 2x is the power. Then minus 1. 1 has no power. Is equal to 53. 53 has no power. Join them together. Bring the like terms together. The terms without powers, let them go together. So the first step, take 1 to the other side, it was negative, it's going to be positive. 9 to power x plus 3 to power 2x is equal to 53 plus 1. 9 to power x plus 3 to power 2x is equal to 53 plus 1 is 54. That is the first step. Next step, my dear student, is try to make the bases to be the same where possible. I'm saying where possible because in some cases it's not possible. Try to make the bases to be the same. I said if it's an even number, when making the bases to be the same, try to start with base 2. 2 to power what? Whether it will give you the same answer. If it's an odd number, the least number to raise as the base is 3. You start with the 3. If it's not possible to make from base 3, you go to 5 or all the other odd numbers. So we have 9 to power x plus 3 to power 2x is equal to 54. Can we make the bases to be the same? Is there a number that we can raise 3 to give us 9? We start with this one. Can we bring this 9 to be base 3? We ask ourselves, is there a number that we can raise 3 to power that number to give us 9? My dear student, I know you are answering it. It's only that I can't hear you. You are saying yes. And that number is 2. 3 to power 2 is 9. So this 9 to power x, you rewrite it as 3 to power 2. That is 9. 3 to power 2 is 9. Then do not forget your x. Do not forget your x. No, do not forget the x of the question. When I tell you do not forget your x, you might overthink. I'm saying do not forget the x that was on the power. So 3 to power 2 is 9. And there was an x there. Then plus 3 to power 2x, the way it is equal to, if you have an addition sign, my dear student, there was a law of indices that was saying if the bases are the same and we have a multiplication sign, we add the powers. Do not confuse that law with this one. These two bases are the same, but we don't have a multiplication sign. Instead, we have an addition sign. So if that is the case, do not raise 54 to base 3. 54 or whatever is on the right hand side of the equal sign should remain the way it is. So we have 3 to power 2x plus 3 to power 2x is equal to 54. Next step, my dear student, we have 3 to power 2x. We have 3 to power 2x. Let 3 to power 2x be any other unknown. Let it be y. Let 3 to power 2x be y. So when we come back to our question, which was 3 to power 2x plus 3 to power 2x, where we have 3 to power 2x, we will substitute with y. So 3 to power 2x, that is y, plus 3 to power 2x, that is y, is equal to 54. Y plus y to y is equal to 54. Divide by 2, divide by 2. Your value of y is 27. You have gotten your y as 27. Ask yourself, 27 is the same as 3 to power what? 27 is the same as 3 to power what? 27 is the same as 3 to power 3. So you have gotten the value of y. You have gotten the value of y. And you had let y to be 3 to power 2x. Remember, you handlet y to be 3 to power 2x, and you have solved for y and gotten y as 3 to power 3. So take whatever you handlet, that is 3 to power 2x, and equate it to the value of y that you have gotten, 3 to power 3. Now the bases are the same. Equate the powers. 2x is equal to 3. You need x. Divide both signs by 2. Divide both signs by 2. X is equals to 3 over 2 or 1.5 or 1.5. That is how you solve such kind of a question. So we are going to have different examples on indices because questions on indices are asked differently. We'll have a question related to this question, but in a different way. We'll have another question, that is example number 3. That was number 3. We'll have example number 4 related to the question we have done, but now in a different way. Question number 4. Solve for x in the following equation. Solve for x in the following equation. I know you are asking yourself, why always find the value of x? Why always find the value of x? We made it that way. So solve for x in the following equation. 49 to power x plus 1. 49 to power x plus 1. Don't worry, when I write another book, I will replace x with other values like k. That is plus 7 to power 2x is equal to 350. Solve for x in that equation. My dear student, this is a question where the two numbers are separated by an addition sign. When you see such a question, in your mind you should know that the 350 should not be raised to base 7. Don't raise this one. At the first step, it should remain the way it is. Ask yourself, my dear student, 49 is the same as 7 to power what? Because now this one is 7. You can't rate for 49 to base 3 or 5. The easiest base, the nearest base, the easiest and least base is 7. Ask yourself, 49 is the same as 7 to power what? 49 is the same as 7 to power 2. Remember, there was another power, x plus 1. Don't forget that one. 7 to power 2 is 49. Plus 7 to power 2x, this one, is equal to 350. Open the bracket. 7 to power 2x, 2 times x, 2x. 2 times 1, 2. So 7 to power 2x plus 2 plus 7 to power 2x is equal to 350. Now, my dear student, that is the current situation of our question. 7 to power 2x plus 2 times 7 to power 2x is equal to 350. Now, this question is somehow different. This is example number 4. This question is somehow different from the that question. This question is somehow different. The that question, it was just 3 to power 2x plus 3 to power 2x is equals to a certain number. But in this question, we have 7 to power 2x plus 2. Now, my student, you are asking yourself, now this question is different from the other one. How should we separate these two powers here? How should we separate these two powers here? And now, my dear student, go back to the laws of indices. The very first law of indices, let me write it. The very first law of indices was a to power x times a to power y is equal to a to power x plus y. You recall that law? Now that means a to power x plus y is equal to a to power x times a to power y, which means 7 to power 2x plus 2, which means 7 to power 2x plus 2, applying this law, is the same as 7 to power 2x times 7 to power 2. As easy as that. 7 to power 2x plus 2, according to the first law of indices, is the same as 7 to power 2x plus times 7 to power 2. Then you proceed with the rest of the question. Plus 7 to power 2x is equal to 350. So you must master these laws of indices so that you become a master of the law of indices and apply that mastery in the laws of indices in solving the questions. So we have used the first law of indices there and said 7 to power 2x plus 2 is the same as 7 to power 2x times 7 to power 2, then plus 7 to power 2x is equal to 350. Now, my dear student, we proceed. We have it 7 to power 2x times 7 to power 2 plus 7 to power 2x is equal to 350. If I ask you, what is the next step? I know you will recall question number 3. Let 7 to power 2x be y. Let 7 to power 2x be y. So here we come back to our original question. It was 7 to power 2x times 7 to power 2 plus 7 to power 2x is equal to 350. So we have let 7 to power 2x to be y. So y times, what is 7 squared? 49. Y times 49 plus y is equal to 350. Y times 49 is 49y. 49y plus y is equal to 350. 49y plus 1y is 50y. 50y is equal to 350. My dear student, you want to get y. Divide both signs by 50. Divide both signs by 50. Your value of y is 350 divided by 50 is 7. 7 is the same as 7 to power what? 7 to power 1. 7 is the same as 7 to power 1. My dear student, after getting y is equal to 7, you come back to where you handlet. You handlet 7 to power 2x to be y. You handlet 7 to power 2x to be y. And you have gotten the value of y is 7 to power 1. What is the next step? Equate. You will equate and say 7 to power 2x that we handlet to be y, 7 to power 2x that we handlet to be y is equal to 7 to power 1 that we have gotten as the value of y. 7 to power 2x that we handlet to be y is equal to 7 to power 1, which is the value of y we have gotten. So since we have 7 to power 2x is equals to 7 to power 1, the bases are the same. The bases are the same, therefore equate the powers. The bases are the same, therefore equate the powers. So we'll have 2x is equal to 1. Divide by 2, divide by 2, and the value of x is 1 over 2 or 0.5. That is how you do such kind of a question. Still on indices, I believe you have understood that concept. Still on indices, we are going to have another example. But before I give you the next example, I'll give you questions on the examples that you have done that you'll try on your own to see or to test yourself whether you have understood. So the next question that you'll do alone and test yourself is solve the equation 16 to power x squared is equals to 8 to power 4x minus 3 is equals to 8 to power 4x minus 3. That one you'll solve it as a question on your own. Question number 2, related to the one that we have just done right now, is this. Solve the equation 9 to power x plus 1 to power x plus 1 plus 3 to power 2x to power 2x plus 1 is equals to 36. Is equals to 36. So you'll do those two questions on your own as we proceed to example number 5 on indices. Remember, all these examples are applying different concepts. That's why you need to understand them. Example number 7, I get it from the Boosting Mathematics Performance. Without using mathematical tables or a calculator, evaluate. Without using mathematical table or a calculator, evaluate 27 to power 2 over 3, 27 to power 2 over 3 times 81 over 16 to power negative 3 over 4 over 16 to power negative 3 over 4. My dear student, evaluate without using a calculator or a mathematical table. First step. The power of 81 over 16 is negative. What did we say on reciprocating? 81 over 16. So we have 27 to power 2 over 3 times reciprocate 81 and 16. 81 over 16 will be 16 over 81. There is a law of indices that we said if we reciprocate the bases, the sign of the power changes. So it was power negative 3 over 4. It will be power positive 3 over 4 after reciprocating. So in that question, the first step is reciprocate 81 over 16 to be 16 over 81. And then according to the law of indices that says, if you reciprocate, change the sign of the power, it was power negative 3 over 4. It will be power positive 3 over 4. Next step, we said 27 to power 2 over 3 is the same as the cube root. Remember what I was saying there? The denominator, the root, to power numerator. So this 27 to power 2 over 3, according to that law, it will be the same as the cube root of 27 to power 2. The cube root of 27 to power 2 multiplied by the fourth root of 16 over 81 to power 3. That is a law of indices that we have applied. Still, we continue. So the cube root, I rewrite it here, the cube root of 27 squared multiplied by the fourth root of 16 over 81 cubed. My dear student, using your calculator, what is the cube root of 27? As a mathematician or a master of mathematics, you'll be able to note that the cube root of 27, even without using a calculator, is 3. 3 is the cube root of 27 squared multiplied by what is the fourth root of 16? The fourth root of 16 means what number can you multiply itself 4 times to get 16? That is 2. The fourth root of 16 is 2 because 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. Times 2, 16. So the fourth root of 16 is 2. Over, what is the fourth root of 81? Which number can you multiply 4 times to get 81? Not a number times 4. You multiply itself 4 times to get 81. It is 3. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So, the fourth root of 16 is 2, and the fourth root of 81 is 3. You only do that if you are a master of mathematics, and then you raise it to power 3. We proceed. What is 3 squared? 9 times, what is 2 cubed? 2 cubed is 8. What is 3 cubed? 27. 8 over 27. We are approaching the conclusion of that question. 9 times 8 over 27 is by 9 1, by 9 3. So the answer is 8 over 3. The answer to that question is 8 over 3. You can continue maybe sending questions or comments on the number that is on your screen as we continue. I will be reading them once you send. So I believe we still have time where we can do another question. Yes? Yeah, we have time to do another question. We have time to do another question. Question number 6. My dear student, once you go through this lesson of indices, you'll never fail a question on indices. Why? We are dealing with different questions the way they appear in KCSE. The way they appear in KCSE. There is no concept that we have done that is similar to another one. So, question number 6 will be, find the value of m. At least they have not said x now. Find the value of m in the equation 1 over 27 to power m is equal to, times 81 over negative 1 times 81 to power negative 1 is equal to 243. 243. My dear student, that is how the question looks like. The first step, is there a question with denominator? Yes, there is a digit with the denominator. Which one is it, my dear student? It is 1 over 27. What should we do to 1 over 27? Reciprocate. What happens when we reciprocate 1 over 27? The sign of the power changes. So, we'll say 1 over 27 is the same as 27 to power negative m. Very simple. 1 over 27. When we reciprocate, we change the sign of the power. If the power was positive m, it will be negative m. Multiplied by 81 to power negative 1 is equal to 243. Is equal to 243. That is the first step. Next step. Do we have a multiplication sign or division? Yes, we have multiplication. This one is different from the one that we were doing earlier. The one that we were doing earlier, this was addition. Therefore, we could not make the base of this number that is on the other side of equal sign to be the same as these ones. But in this case, it's a multiplication. If it's a multiplication or a division, then we make all the bases to be the same. Which is the least base that we can raise it to? 27, 81, and 243. All of them are odd numbers. Can we raise them to base 2? I know. Why? 2 is an even number. Can we raise it to base 3? Yes. We can raise it to base 3. Why? It is an odd number. So, we ask ourselves, 27 is the same as 3 to power what? 27 is the same as 3 to power 3. Into bracket to power negative m times 81. My dear students, 81 is the same as 3 to power what? 81 is the same as 3 to power 4. Remember, there is a negative there. Is equal to 243 is the same as 3 to power what? My dear student, 243 is the same as 3 to power 3 times 3, 3 times 3 times 3 times 3 to power 5. 3 to power 5. The first step is making the bases to be the same. Open the brackets. So we'll have 3 to power 3 times negative m is the same as negative 3m. So 3 to power negative 3m multiplied by 3 to power 4 to power negative 1 is the same as 3 to power negative 4 is equal to 3 to power 5. My dear students, all the bases are the same. If the bases are the same, and we have a multiplication sign, we add the powers. Drop the bases or ignore them and add the powers. So we'll have negative 3m plus negative 4 is equal to 5. Negative 3m, positive times negative is negative, minus 4 is equal to 5. Negative 3m is equal to 5 plus 4. Negative 3m is equal to 9. Divide by negative 3, divide by negative 3. My dear students, the value of m is equal to negative 3. That is a different concept of a question on indices, and I believe that you are understanding. Let me check whether there is time to do another question. Let me check whether there is time to do another question. We are not going to do another question, but I'll give you questions that you'll do within the remaining 5 minutes that you'll do on your own, so that you test yourself. Solve for x. I gave you 2 questions, so I'm giving you another one. Solve for x in the equation. Solve for x in the equation. solve for x in the equation. 5 to power 2x, 5 to power 2x minus 6 times 5 to power x plus 5 is equal to 0. The last question I'll give you that you'll do it on your own. So for x in 5, this is number 3. I gave you number 1 and 2. Number 4. So for x in the equation, 5 to power 2x minus 1 is equal to 12, is equal to 12 to power x. Yes, thank you for your comment. Hello teacher Kelvin, ni George from Nyeri. Una explain vizuri sana. Thank you very much. George. Hello. Hi. Ni David from Nairobi. Good work. Keep it up. Thank you, David. Hi teacher Kelvin. I'm John from Kiambu. You are teaching so well. I need that book. Yeah, I'll give you direction how to get the book. Thank you for your comments. Thank you for the lesson. Before I conclude, I have Boosting Mathematics Performance Revision book. That is the book he was asking for. This book, Boosting Mathematics Performance KCSE Mathematics Revision book, is a book written by teacher Kelvin Fudi Wanyambura. A very good book with both paper 1 and paper 2, section 1 and section 2 work divided very well for your easier revision, and you can get this book for you to achieve the best in mathematics. For you to get this book or even to send me the workings of the questions I've given you, you can contact me through WhatsApp 0705 845 747 0705 845 747. Thank you very much, my dear students, for being with me in the course of the lesson. My name is teacher Kelvin Fudi Wanyambura from Lakewood Senior Girls High School. May God bless you abundantly, and remember to pray before you do anything. Never give up. Thank you.
Access to knowledge